Hello, good morning friends. Today we are going to learn our module number 2 vector spaces, and today's topic is linear dependence of vectors. In the last lecture we already learned how to check the linear independence of vectors. Now today we'll learn linear dependence of vectors. So let us first define what do you mean by linear dependence of vectors. If a set of vectors is given where the elements of this set may be v1, v2, vr and each having some dimension. So a set of r vectors v1, v2, vr is said to be linearly dependent if there exist r numbers, and these r numbers can be taken as k1, k2 up to kr. And if these r numbers are present but is not all zero, such that the relation k1 v1 plus k2 v2 plus k3 v3 plus dash dash kr vr is equal to 0. The meaning of this, that is k1 k2 k2 not all 0, even though if k1 k2 up to kr minus 1 are 0 and only kr is equal to 0, we can say that this is linearly dependent. So it is not compulsory that all are 0, like in linear independence. If all are 0, this is linearly independent. In this case, this k1 k2 kr, if this not all 0, then the given set of vector is linearly dependent. To understand this, let us see one example. So examine whether the following vectors are linearly dependent or independent. And if dependent, now here we learn how to find the relation between them also. So the vectors are 1 minus 1 1, second vector will take 2 1 1, and third vector as 3 0 2. Let us denote these three vectors by some notation, that is v1 v2 v3. So let us denote first vector as v1 is equal to 1 minus 1 1, v2 is equal to 2 1 1, and v3 is equal to 3 0 2. Now we have three vectors with us, v1 v2 v3. Now what we'll do, we'll write one equation, that is our k1 v1 plus k2 v2 plus dash 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 kr vr is equal to 0. But since here we have only v1 v2 and v3, we'll write only k1 v1 plus k2 v2 plus k3 v3. Otherwise our definition is for r vectors. Here we have r vector is 3, that is r is 3, so we have 3 vectors, and the right hand side is 0, where all the elements of these 0 vectors contains 3 elements. So now let us put the value of this v1, v2 and v3 from the given equation, or from the given value. So let us put the value of this v1 here, value of v2 here, and the value of v3 here. So if you put the values, what will you get? Therefore k1 into 1 minus 1 1 plus k2 into 2 1 1 plus k3 into 3 0 2 is equal to 0 vector, which contains 3 elements. And now multiply first element with k1, here first element with k2 and first element with k3. So we'll get first equation, then the right hand side is 0, so we'll get k1 plus 2k2 plus 3k3 is equal to 0. Similarly for second element, now we have minus k1 plus k2 plus 0 k3 equal to 0. So second equation will write minus k1 plus k2 plus 0 times k3 equal to 0. And similarly for last element, we can write k1 plus k2 plus 2k3 is equal to 0. Now we have to solve this system of equation for k1 k2 k3 now. So how to solve it for k1 k2 k3? To solve it for k1 k2 k3, we'll apply the same method of row transformations to get k1 k2 k3, which we already use for linear independence of vectors. So here these three equations are there. Let us first write down the matrix form of this equation, that is Ax is equal to B form, where A is nothing but the coefficient matrix obtained from these three equations, B is the right hand side, that is 0, and X is the vector of unknown, that is k1 k2 k3. These are unknown, so we have to find out. So let us write down in matrix form. So in matrix form, the first row gives 1 2 3 from first equation, from second equation we'll get minus 1 1 0, and from third equation we'll get 1 1 2, and k1 k2 k3 are the unknowns, and 0 0 0 is the right hand side. Now to find this k1 k2 k3, let us reduce this element into 0, this element into 0 by applying row transformation. This is our r1, this is our r2, this is our r3. So we'll first write r2 plus r1, so we'll get 0, and then we'll write r3 minus r1, so that this element becomes 0. So to make these two elements 0, we are applying the row transformation as r2 plus r1 and r3 minus r1. So let us apply this. When we apply this transformation, first row is same 1 2 3. Now second row will change, minus 1 plus 1 from these two elements will get 0, then 1 plus 2 3 here, then 0 plus 3, 3 again. Then last row, that is this third row, subtract from first. So 1 minus 1 will get 0 here. Then 1 minus 2 is minus 1, and then 2 minus 3 is minus 1. K1, K2, K3 unknowns as it is, and the right hand side 0 as it is. Now again we have to simplify this further. So to simplify, now we'll apply 3R3 plus R2 because we want to convert this element into 0. If you multiply it by 3, it becomes minus 3 plus 3. So this element become 0 and we'll get the required upper triangular or echelon form this matrix. So apply. First row is same, second row is same. In the third we'll write 0, 0, 0. And here we'll get K1, K2, K3 are the unknowns, and right hand side is again 0, 0, 0. Now here if you observe, this last row completely becomes 0. This clearly indicates that the given vectors are linearly dependent. In linear independence, this last element is not equal to 0. This is some non-zero number. But here if you are getting all the elements of a row are 0, sometimes you will get this second row as well as third row as 0. Then we say that the given set of vectors is linearly dependent. But we have a question. If the given set of vectors is linearly dependent, then we have to find out the relation between these vectors also. So how to find this relation? So to get this relation, let us first find out this K1, K2, K3 now. So now here we have two equations. So what we'll write from this first row, we'll write down one equation, that is K1 plus 2, K2 plus 3, K3 is equal to 0. From second row again, we'll write down one more equation, that is 3K2 plus 3K3 is equal to 0. So now we have two equations and unknowns are 3. We have two equation and unknowns are 3. So how to solve this two equation with 3 unknowns? To solve this two equation with 3 unknowns, we'll apply in this way. We have 3 equation. Number of equations are 2. Number of unknowns are 3. So 3 minus 2 is equal to 1. So one unknown can be assigned any arbitrary values. Any arbitrary values means the answer will come in terms of t. So generally we'll take this third variable k3 as t and we'll try to find out k1 and k2 in terms of t, and we are denoting this as equation number 1, equation number 2. So let us put first k3 is equal to t. If you put k3 equal to t into, what will get? If you put k3 is t, so clearly implies the value of k2 is equal to minus of t. Now put k2 equal to minus t in 1, k3 equal to t also in 1, so to find out k1. If you put the values, therefore we can write here, put k3 is equal to t and k2 is equal to minus t in 1. Therefore 1 becomes k1 minus 2t plus 3t equal to 0, or which clearly implies k1 is equal to minus of t. So now we got the value of k1 in terms of t, we got k2 in terms of t, and k3 is already in terms of t. So clearly the given set of vectors are linearly dependent because these are depending on t. Now after this, let us find out the relation. To get the relation, what we'll do, we'll put this k1, k2, k3 in our star equation. That is, this is our star equation. We'll put the values of k1, k2, k3 in terms of t here. So if you put the value, what we'll get, minus t times v1 minus t v2 plus t v3 equal to 0. But you have to find out the relation between v1, v2 and v3. So let us divide this equation by t. So that is t get cancelled from each term, and we'll get minus v1 minus v2 plus v3 equal to 0, or in short you can say v3 equal to v1 plus v2. This is the relation between these three vectors. That is, one vector can be expressed as an addition of two vectors in this case. Sometimes we'll get v3 is equal to subtraction, or sometimes we'll get the multiples of these, that is 3v1 plus 2v2, and in such a way that. And once we get this relation, we can 100% claim that the given vectors are linearly dependent. So today we have learned, if the vectors are given, if a set of vectors is given, then how to check its linear dependence with the help of this single equation. If you are getting k1, k2, k3 in terms of t, then clearly we say that the given vectors are linearly dependent. If k1, k2, k3 all are 0, the given set of vectors is linearly independent. Thank you.